Here's an example of a free response problem that is an optimization problem. We've been given a function f, where we've been told it's piecewise. I didn't label it for you, but this is f of t, and f of t is piecewise. The first piece, the part on the domain from 0 to 4, has this polynomial function, and in the other places, f is piecewise linear. So those other parts that look like lines, they're just confirming for us they actually are lines. So we have been asked for the time interval 0 to 24, so that's what's shown on the graph here, 0 to 24, at what time is f increasing at its greatest rate? At what time is f increasing at its greatest rate? So your biggest job here, I think the hardest part of this problem, is answering question 1. What quantity are you trying to optimize? Obviously we are trying to, whatever it is, we're trying to maximize it. We want its greatest. It's the greatest something. So I have to think about what this is. At what time is f increasing at its greatest rate? So the thing that we want to maximize, the thing we want the biggest value for, is the rate at which f is changing. Well, what would you call the rate at which f changes? That's what the derivative is. Derivative means rate of change. So step number 1, the quantity we want to maximize is the derivative of f, which we could label f prime of t. So step 2, so step 2 is to write a formula, write some kind of function for the thing we're trying to optimize. So we're going to write an expression for f prime of t. Step 3 is going to be to find the derivative of f prime of t, because we're going to need critical points for f prime. We find critical points by setting the derivative equal to 0. Notice the function we're trying to optimize is a derivative already, so we're going to need the derivative of that derivative. Okay, so just keep it straight. We want to optimize f prime, so we need critical points of f prime, which means we're going to need the derivative of f prime to equal 0 or be undefined. Okay, so here's what I've written up so far. You'll notice that nobody's expecting you to write out steps 1, 2, 3, 4, 5, 6, 7. Those are just my 7 steps. It's not like a real thing, but I hope you will find them useful. I'm writing them out just to help you kind of get the hang of it. I have no expectation that you would do the same, so feel free to just show this work instead of writing out all these numbers like I am. So how can I... Okay, so I've got this little wrinkle here. I think the interesting part of f prime, the interesting part of f is the first piece of this piecewise function. So when I go to find f prime, I'm going to have to consider the other pieces. But the interesting part, and I'm going to have to squint here to find this derivative. To take the derivative of f prime, I'm going to start by taking the derivative of the first piece. So the 3 is going to come down to the front, and I'm going to get negative 3/4 t squared plus 3t. So that's one piece. Where else might f prime exist? So f prime here is 0 because the slope of that line segment is 0. Same here. All right, so I might also like to know that f prime here, f prime, this is a graph of f, so f prime is going to be the slope of this little linear piece. So this is not official notation, but there are 3 different answers for what is f prime of t. There's one piece where it's negative 3/4 t squared plus 3t. There's a second piece where where f prime is equal to the slope of that last little line segment I just circled, and I drew all over the lines so I can't see the numbers. Hold on one second. All right, for that first uphill linear segment, the slope, I'm just going to use change in y over change in x. That works if slope of a line is constant, so I can use any 2 points on that line. And I find the slope there is 3/2. That means f prime of t sometimes equals that polynomial function, sometimes equals 3/2, sometimes equals 0. I should have put 0 in my list. Sometimes equals, the slope of that last line, that's the one going downhill, is negative 3. Okay, so I do need to know about f prime. I'm looking for critical points of f prime, and I am going to do that by finding f double prime, letting it equal 0, or finding where it's undefined. So when I go to find f double prime, I'm going to bring this 2 to the front, so it's going to be negative 6/4, so negative 3/2 t plus 3. Now, the derivative of f prime everywhere else is going to be 0, right? Because everywhere else I had a slope that was constant. Derivative of a constant is 0. So when it's time to figure out critical points by letting f double prime equal 0, this is the only piece of the piecewise function I have to perform that with. So when I let f double prime of t equal 0, I get t equals 2. So that's subtract 3, multiply everything by 2, and divide by negative 3. So time equals 2. So step 5 is to put together this list of all the locations where I might have my absolute maximum. So those are going to be at, what I have is a picture of f. What I need is critical points for f prime. So don't assume we can look at this picture and get f prime values. This is a graph of f. All right, so my possibilities, I know I had this one critical point, time equals 2. I also have this other problem, which is that critical point, it's only a critical point for well, there I go. I circled something on the f graph. We're really not talking about the f graph. We're talking about f prime is what's interesting, but it's just that first piece of the piecewise function that I found a critical point for. I'm going to have to also consider f prime in some other places. So remember that list I had? And it's funny because you can't really pick an exact time value, but there was another place on the graph where f prime equaled 0. And there was a place on the graph where f prime was 3/2. And there's a place on the graph where f prime equaled negative 3. So I'm going to have to include those other values for f prime in there, even though they didn't come from finding a critical point, because the only place I was able to find f double prime was on that first piece of the piecewise function. So when t is 2, what is f prime of 2? Oh, I found my error. It's negative 3/4 t squared plus 3 times t, so fix that up. Negative 3/4 times t squared plus 3 times t, so that's negative 3/4 times 4, which is negative 3 plus 6. F prime of 2 is 3. So when I look through my list of, I guess that was step 6, was filling in the f prime values, the second column of my table. Now I'm going to look through my list, and remember I was trying to maximize f prime, so I'm looking through this list for the biggest f prime value. That happens when time equals 2. I have a f prime value of 3. So once I find that, I'm going to be able to write up my final answer. All right, this is what I wrote. Notice that we've been asked to show the reasoning that supports our answer. So I want to make sure that it's very clear to the AP reader what my thought process was. So I've written f is increasing at its greatest rate at time t equals 2 seconds. So a good thing to notice, did they actually ask us what that greatest rate was? No, they say for what time t is an input. Here is the input. This time they're asking about the input value at which the output is greatest. So f is increasing at its greatest rate at the time t equals 2 seconds. When time t equals 2, f prime of t equals 3, which is the maximum value of f on that interval from 0 to 4. So that's the maximum value of f prime. Thank you for your patience. That's absolutely the absolute, which is the maximum value of f prime. Make sure you put a little prime in there. Now I just have a big blob there, but that's f prime on that first piece, the interval from 0 to 4. And because that same 3 answer is bigger than f prime on any other interval. So it's this critical point analysis, critical value analysis that makes us know 3 is the biggest f prime on that first interval where I actually had something I could take the derivative of. And then I have to compare it against these other slope values, which I did. And when I compare them, the 3 is the largest result, largest f prime value. So I make this conclusion that at time t equals 2, that's where f is increasing at its greatest rate.